I'm 14. I live in Oakland, and I'm working with my mentor, Zachary Herman. So I made a program that visually represents sorting algorithms. Sorting algorithms are programs that take a list of numbers and put them in order from least to greatest. I programmed two algorithms for this, merge sort, which takes a list of numbers, divides it into many, many lists, each with one number in them, and then sorts them back together into one sorted list. And insertion sort, which creates a sublist within the list that is sorted and moves the elements from the unsorted list into the sorted one. I use Python and Pygame for the visual part. My favorite feature is how it intuitively represents sorting algorithms, which are kind of a confusing concept for me at least when I first learned about them. And the most difficult aspect of them were rewriting merge sort to work with the program. It's the way we had written it, it didn't really work. And finding a good beep sound effect. It's really, really difficult to find one, surprisingly. And so, what's this? And so we have two programs, first of which is merge sort. Oh, sorry. Merge sort. No. This is going well. This creates a random list, and so you can see it creates two lists and then sorts it, and then at the end it throws this green line. We also have insertion sort. Which you can see takes the smallest element and moves it towards the front of the list. And it looks like we have three of the exact same element, oddly enough. This is truly random. And so this is much slower than merge sort, as you can see, because it has to look at every element and figure out where it belongs in the list. So generally, programmers will use merge sort. It's pretty much the fastest sort. But in some cases, like if you're expecting a lot of sorted lists, then insertion sort is actually better. Like if we do merge sort with an already sorted list, which I have here. With one hand. Merge sort takes exactly as long with an already sorted list as it does with an unsorted list. So if you're expecting a lot of sorted lists, it's going to not be the best idea. See, it still checks every element, even though it's already sorted. Whereas with insertion sort, it will just go immediately instead of. It will go immediately instead of. It'll just check immediately instead of having to go through all of it. And then finally, we could have one more sort. This is kind of a joke sort. If you give this sort a list longer than 7, it will not stop before the heat death of the universe. This is Bobo sort. It checks to see if the list is sorted, and if it isn't, it randomizes it and checks to see if it's sorted again. And does this over and over and over and over forever. Thank you, I guess.